Problem A. How many ordered pairs satisfy the following expression? So I don't know any other better way except to guess and check from the solution. So if that's the case, what can we say? We can say x to 2020 plus y minus 2 is equal to 0. In this case, how can we solve this question? So now that we have it in this format, let's try x is equal to 0, and let's try special cases, x is equal to 0, x is equal to 1, x is equal to negative 1. Because obviously, this big of an exponent, you want to try small values first. So x is equal to 0, that means y times y minus 2 is equal to 0. That means y can either equal to 0 or y can equal to 2. So they have two cases. What about x is equal to 1? If I have x is equal to 1, then I have y squared minus 2y plus 1 is equal to 0, which is equal to y minus 1 squared is equal to 0, which becomes y is equal to 1. The same goes for x is equal to negative 1, because remember, this is a positive or even exponent, so this becomes y is equal to 1 as well. Now that we have four possible cases, we can eliminate A, B, and C. We only are left with D and E, but how come it's not E? Let's try it, okay? Obviously, if it's infinitely many, that means x can be any possible value. Notice, x to the 2020 will always be positive, okay? So that means y times y minus 2 will be equal to a negative quantity. Better yet, let's try to prove that it can be possible. Y squared minus 2y. That looks awfully like a perfect square. So let's just do minus 1 plus 1 is equal to 0. Becomes y minus 1 squared is equal to a negative number, a very large negative number for that fact, plus 1. Now, a very large negative number plus 1, well, that will still be ultimately a negative number. A negative number can never be the value of a perfect square function, because remember, the graph looks like this. And the graph, oh, that's terribly drawn, but what I'm trying to say is the graph never goes below the x-axis where it's negative. Therefore, the answer choice is 4 and not infinitely many.